Hey folks, I think I'm live. Let me just check if everything is okay. Yeah, I think I'm live. Yeah. Let me just check if audio and everything is all right or not. Just give me a sec. I'll just validate that. Just check if everything is okay. Yeah, things seem to be okay. And thanks to everyone who has joined in on a Saturday evening. We'll wait for a few minutes and we'll get started with a very exciting session, a very important session in C programming related to pointers and strings. I'm looking forward to this. So let's just wait for everyone else to join in. So yeah, I'll stay on the call for a while, and yeah, people are coming in, and yeah, let's wait for everyone to join in. Hey, good evening, folks. Thank you for joining in, and yeah. So we have an exciting session of very interesting questions. I'm looking forward to solving them with everyone, and yeah, let's see. By the way, just wanted to convey this, which is. Now since we have covered significant portion of C programming, because typically what happens in the GATE exam is you get a lot of questions from functions, from control statements, and especially pointers, right? There are a ton of questions actually. So I'll keep adding more and more solved problems, because now we have reached a stage in C programming where we can dive into more and more problems which are at GATE level. Earlier with simple operators, it's hard, because most GATE questions are not just at operator level. They typically go into more complex concepts. So we'll solve more problems, and yeah, if everything goes well, we should be ready for the next batch and for the next subject by 18th or 19th, as per our plan. Worst case by 20th, right? We want to give you some subject-wise tests and stuff like that. Hey, thank you, folks. I'm happy that you like the videos on pointers. Pointers are extremely important concept. I mean, pointers are my favorite concept. Again, in some of the problems that we have today, we go into 3D. We go into multidimensional arrays and pointers and how they work. That's very exciting, because those are the tricky ones. So anyway. Okay, sounds good. The next subject for batch 2, we're just thinking about it, Ayush, because we've gotten a lot of calls from students for stating, both from batch 1, batch 2, and students who've joined us for batch 3 already, that they have exams around the especially students who are in the final year of BTech, that they have exams around late April, early May. So we're trying to do some simpler subjects. So we're just still deciding it. We'll get back to you. We'll get back to you in a couple of days with what is the next subject that we'll cover. So we are caught between whether we should do aptitude or whether we should do aptitude or whether we should do some maths concepts. Maths, of course, I'm not willing to start discrete maths, because discrete maths is super duper important. So we could do some linear algebra, some calculus, and things like that. We're still caught between those options, because I don't want any students who, I mean, of course, let's be honest here, right? If some students have exams, I don't want them to suffer. I don't want to cover a very important subject like discrete mathematics or databases, etc. So we are caught in that dilemma, but we'll get started with it. Okay. Yeah, Ayush, you're right that late April, early May is when a lot of students have exams. So we're trying to fit that thing. And if the exams start from late April, people will start preparing, brushing up their concepts from the 3rd week of April or so. So we want to accommodate everyone. But again, we don't want to slow down other students also. We want the content to continuously go. It might be low priority subjects which have either less weightage, or easy subjects that students can cope up even after the session is over. For example, if you have exams and you missed, let's say, aptitude, you can always go back to aptitude and solve them at your pace, because it's relatively an easier subject, right? So we're still caught up in that. We'll just announce that in a couple of days. Okay, sounds good. So let's get started. Let's get started now. Where are we? Just give me a sec. I'll change the screen. Full screen. Yeah, we are on full screen mode. Let's go. Sorry. Okay, let's go to the questions. Okay, let's go one by one. I'll dive into these. And where are we? Just a second. Let me just hide this. Okay, so let's go question by question. These are some very exciting questions out here. Okay, so let's look at this snippet of code. What is the output? I hope everybody can see this. Let me just verify. Okay, so everybody's seeing this, right? So thankfully, okay. So let's go for this very first question, right? So it says int main you have a character. So you have two characters. So you have two strings. Your first string is just %d %c is a string constant that you have in str, right? Similarly, you have a character array called r, which has applied course, right? Now look at this. How does your printf work here? This is very interesting, right? So printf, the first parameter of printf is actually a string, right? Right? If you recall, the first parameter of a printf, we discussed this when we learned about string constants and things like that, right? So here, what do we have? In str, you will have %d %c space %c. Sorry, sorry. Let me write this carefully. %d %c, which is perfectly all right. What about 0 ARR? What does 0 ARR mean? What does this mean? This is same as array of 0, right? This is same as array of 0. We discussed this equivalence, right? When we learned about pointers and array similarity. And we showed that this is nothing but array plus 0, which is nothing but 0 plus array, which is nothing but array plus 0, array 0. Okay, we discussed this notation and shown that these two are equivalent because everything internally gets converted into pointer notation in the course videos, right? So what is the first parameter that it would print? It would print array of 0, and it would print it as an integer because there is %d here. So what is array 0? Array 0 is a, right? It is a, right? So what is the ASCII? So because you're trying to print the integer value of a, it would print 65, right? So it would print 65, which is the ASCII value of a. Now comes the second part. Look at the second part. What is the second part? 3 ARR plus 4. What is this equivalent to? Look at this. What is this equivalent to? Okay, so this is same as, look at this. Let's try to convert it into basic notation, right? Because every character takes 1 byte, right? This can be written as ARR plus 4 plus 3, because every character, literally every character takes just 1 byte of space, right? So this can be written as ARR plus 4 plus 3, which is nothing but ARR plus 7, right? Which is nothing but ARR plus 7. That's what it is, right? So if you think about what is ARR plus 7, this is nothing but ARR in the 7th position, right? So all these are equivalents. All these are equivalent. So what is ARR 7 now? This is 0, 1, 2, 3, 4, 5, 6, 7, right? C. And what are we printing it as? We are printing it as a character, because if you look at this string, we have %d space %c. So this C would be printed as a character. So you'd get 65 space C. So option B is the right option here, right? So very simple question, very straightforward. You just have to understand how this and this have to be converted into array representation or pointer representation. If you understand that array and pointer representation equivalent concept, this is a straightforward question. Okay, so now let's go to question 2, right? So now let's go to question 2. So what is question 2 here? Okay, looks straightforward. So I have a function called foo. Okay, I'm just declaring the function here. Then I have main here. What am I passing? So I have a character array called C, where I'm sending this sentence here, this string basically, not a sentence. I'm sending this string here, and this is anyway, this is passed by reference. So this whole C would go here. So what is A now? Now A is nothing but a pointer to this string, DELIPPA space ESROUC. Okay, this is space. There is a space here. There is a space here. So wherever there is a space, I'll just put this underscore or a blank like symbol just to show that there is space. Now, how does foo work here? Look at this. So what did we pass to foo? Okay, we passed foo. We passed this whole string. We passed this whole string through A. Okay, so we passed. Okay, anyway, the string is written here, right? So let me write it more carefully, because A ESRUOC. Okay, this is a twisted reversed word here. What does it say? If, look at this condition. Again, this is a recursive function because I'm calling foo within foo, right? So how does this work? It's saying if star A. What does if star A means? It means if star A equals to null, right? Or not equal to null, sorry. If star A is not equal to null, and this is logical and if star A is not equal to blank, a blank space. This is a blank space basically. So what is star A means? This implies as long as star A is not equal to null, is not equal to 0. So what is 0? By the way, in characters, what is 0? 0 is nothing but \0, right? Because I told you that \0 has an ASCII value of 0, right? So this terminating character has an ASCII value of 0. So as long as star A is not equal to 0, which means as long as it is not equal to \0, and as long as it is not equal to this space, look at this. If this is not true, if A is not pointing to a null character, and if A is not pointing to a space, then call foo A plus 1. So first time, what am I going to call foo with? I'm going to call foo with this whole thing, right? With A pointing to this. Next, I'm going to call foo with A plus 1. What does A plus 1 here mean? A plus 1 basically means this is the 0th character, this is the first character, right? So the next time I'll call foo with this ELIPPA space ESRUOC. This is what I'll pass when I call foo the next time. Because look at what am I passing here? I'm passing A plus 1. The pointer that I'm passing is now to the second character, not to the first character, right? Now again, so after again I'm calling foo now. Okay, when I call foo, what happens? Again it will check. Is this character the terminated? See, what is it doing? Is this a terminating character or is this a space? It's not a terminating character, it's not a space. So it'll again recursively call. It'll again call with the next character. So again it will call, if you look at this, again it will call foo with this ESRUOC. Okay, so first we called foo. This is the first we called foo with the whole thing. Second we called foo with ELIPPA. Third time we called foo with LIPPA. Right? We're continuously calling. So we keep calling till the time we encounter a blank space or we encounter a null character. Okay, in this string, we'll keep calling it. Again, we'll call foo with this, then 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 we'll call foo with this. Finally, we'll reach here. When we reach here, it will not go into this if condition. Look at this. It doesn't go into this if condition. It will simply return null, right? It will not return because it will basically return because the return type is anyway void. So till the time we reach a blank space because of this condition, till the time we reach a blank space or the end of string, we'll keep continuously calling foo. And when this whole recursion unwinds, look at this. This recursion will completely unwind, right? When the recursion unwinds, I'm basically using this put char to print the character. So what will happen now? By the way, this recursion will keep going on. First, I'll start with this whole string. Next, I'll discard the first character and I'll pass the whole string. Then I'll discard the first two characters and pass the whole string, so on and so forth. At some point, when I encounter space or when I encounter the null character, the recursion will stop and I will unwind the recursion. As I unwind the recursion, I am printing the character. So what characters will be printed? First, I'll print A. Because the recursion unwinds like this, right? The recursion will unwind like this. So I'll first print A, then I'll print P, then I, then E. So I'll literally print applied as the recursion unwinds, right? So this will actually print A. Okay, so what this function does is, given a string, what this function is doing here is, given a string, it will keep going on till the time it finds the end of the string or it finds a space. And from the place it finds the space or the null character or the end of the string, it will keep printing each of them backwards. That's what this whole thing is doing with recursion put in here. Okay, I hope this is clear. So option A is the right option. Okay, see, there are two parts here. There are pointers here and there is recursion. Both concepts are being tested in a single snippet of code. Okay, very interesting piece of code. Again, very simple if you're careful with code. Okay, let's look at this. Oh, this is a fun problem. Okay, I love these problems. I love these 3D array problems. Again, let's solve this very, very carefully and very patiently, even if it takes a little more time, because this will help us understand. The whole 3D arrays much better. So I'll do this slowly. So what is the 3D array that we have? Okay, we have a 3D array, right? I have 3 2D arrays. Each 2D array is of size 4 rows and 2 columns. So let's actually draw it. Okay, I have 3 2D arrays, right? What is the size of 2D array? Each of these 2D arrays is 4 rows and 2 columns. So let's actually write it down. Okay, so 4 rows, row 0, row 1, row 2, row 3, and 2 columns. Okay, so again, I have 3 such arrays, right? I have 3 such arrays now. All right, this is my A0. Look at this. My A0, if I say A0, my A0, look at this. My A0 is a 2D array pointer. Okay, remember my A0 is a 2D pointer to this 2D array because my A is a 3D array. Okay, similarly my A1 is a 2D array. My A1, okay, let me write it down more clearly here instead of, so let me write it down better here. My A1 is a 2D array, pointing to, my A1 is a pointer to a 2D array pointing to this. Okay, then my A2 is a 2D array pointing to this. Now look at what I've initialized. It'll initialize everything in row major order, right? As we discussed. So this value will be 1, 2, 3, 4, 5, 6, 7, 8. First A0 is filled, then A1 will be filled. 9, 10, 11, 12, 13, 14, 15, 16, then 17, 18, 19, 20. See, I've only given 20 values here. There are more places here. There'll just be garbage values in here. There will simply be garbage values here. Okay, so this is how my 3D array looks like that. If you want to think about this 3D array, you can think about it like this also. You can think about it like a cuboid also. This is my first 2D array, then I have a second 2D array, then I have a third 2D array. But instead of looking at it, I've placed each of these arrays separately here so that it's easier for us to see what value is in which cell. Okay, I hope this is clear till now. Now let's go into it. Okay, what is the problem asking? The problem is saying printf. Okay, let me just erase this. Okay, it's very, very important that you understand this. I'm just using row major notation. This is my A0, this is my A1, this is my A2. Now look at this. Now look at this complex looking thing. Okay, let's actually break it down. What is the innermost thing that we have? We want to printf %d. Okay, what is the output of this code? Now let's look at it step by step. A plus 2. What is A plus 2 mean? Okay, A plus 2 is nothing but A2. Right? A plus 2 is nothing but A2. And what is A2? A2 is a 2D pointer to this whole 2D array. That's what A2 means. Look at this. That's what A2 means. A plus 2 means, or A2. They're the same thing, right? A plus 2 can be written as A2. It's one and the same. Right? Now you have star. Look at this. After A plus 2, star is there. Now what does star mean? Okay. Star A plus 2. Star A2 or star A plus 2 now. What does it mean? It means value stored at A2. Now what is A2? A2 is a 2D matrix. The moment you say star A2, you get a 1D matrix that is going to point to. So this is going to be a 1D matrix. Look at this. This is going to be a 1D, not a matrix, This is going to be an array to a 1D, this is going to be a pointer to a 1D array. I'm getting confused. Okay, so let's go step by step. A20 is basically a pointer of type 1D array, right? Pointing to A20, which means it is literally pointing here. A20, look at this, A20. It is a 1D pointer. Okay, pointing to this row, pointing to literally this row. Now, after this star, I'm saying -3. Look at this. I'm doing -3. So what does -3 now imply? So I'm not writing the whole thing again. So my A20 -3 is what it is saying. What is A20? A20 is a one dimension. It's a pointer to a 1D array pointing to this row. Okay, when I say -3, what happens? I'll go 3 rows back. Look at it. When I say this, I go 3 rows. 1 second. Yeah. So when I say 3, I go 3 rows back. This is the row that I am at. First row back, second row back, third row back. So this is what I will obtain. So I'll get a 1D pointer, right? I'll get an array to I'll get a pointer to a 1D array pointing to. So this is what I get when I do A20 -3. Look at this. Why am I going rows back? Because this is a pointer to a row. So when I subtract 3 to it, I'll go 3 rows back in the sequence. Look at this. This row, this row, this row, this row, then these 4, then these 4. Right? So if I'm here, if I do -3 rows, what does it mean? 1 row back, 2 rows back, and 3 rows back. This is what A20 -3 means. Okay. So this is what A20 means. 1 second. 1 second. So a plus 2. Okay, so let's go here. 1 second. So a plus 2 is 1 second. I think I made a mistake somewhere. Just a second. Just a second. Just a second. Give me a second. So a plus 2. A plus 2 is, I am at A, right? A is a 3D pointer, right? A is a 3D pointer. So a plus 2 will give me a plus 2, right? A plus 2 will give me star a plus 2. Sorry. I think I made this mistake here. Okay. So this is important. Sorry. Star a plus 2. Sorry, I think I made this mistake here, right? So 1 second. Star a plus 2 is A2, right? Star a plus 2 is A2, right? Because a plus 2 will take me here. A2 will give me, just a second. I'm getting confused here. Just a second, folks. Did I make an error somewhere here? Star a plus 2. Okay, just excuse me for this. Let me think through it. I'll again send you a video answer for this. I think I'm getting confused here with the notation. Okay, I'll clarify it again. Sorry for this. Sorry for this mess up. I'll just sit through it and do it more peacefully. Okay, let's keep this question on hold. I'll do it more peacefully. Okay, I'm messing it up here. Okay, so let's go to question 4. Instead of wasting time on this, I'll come back and solve it. I'll solve it peacefully, draw it again. I think I've written my notes incorrectly somewhere. That's why I'm messing this up. Okay, so I'll go to question 4. My mistake. Sorry for this. I'll correct it. So let's go to question 4, right? So now what is this question 4? Okay, so let's go to question 4. Just a second. Let me just look at question 3 once and let me see if I can correct it. Just a second. I think I'll have to redo it carefully. I'll have to redo it carefully. So a plus 2 is just 1 second. What do we have here? We have a plus 2 here. A plus 2 is an address, right? A is basically a 3D pointer. A plus 2 is an address. Anyway, I think it's just better if I resolve this problem and send it to you. Sorry for the goof up. It's slightly tricky, and I think I messed up my notes a little. My team is trying to correct me, and I think I messed it up. Sorry. Anyway, I'll send you a more detailed answer. Okay, sounds good. So this is a much more easier problem. Let's go with it. Okay. Again, these problems can be extremely confusing. These problems can be extremely confusing, to be honest. Okay, so let's go with this question. It says int main. So I have character pointer pointing to applied course. Okay, so this is this is perfectly all right. This syntax is perfectly all right. And now I'm trying to print a character. I'm trying to print a character, not a string here. What am I trying to print? Star pointer, star pointer, star. Okay, so let's look at this. So what does this mean? This means, see, we'll see, all these are unary operators, right? So we'll start with this, right? So star pointer. Okay, again, unary operators, as you know from the auto rule, unary operators have right to left associativity, right? Because they have right to left associativity, right? They have right to left associativity. Yes. So star pointer basically means the address of this pointer. Sorry, the value stored at this pointer, right? And then the address of it, then the value stored at it, the address of it. Now so a star and an address of cancel each other, right? If you think about it logically, because this is saying, so if I have some pointer p, what does this mean? What does this mean? This means the value stored at this pointer, for that you're trying to compute the address of it. Address of the value stored at pointer p, which is nothing but p itself, right? So this star and pointer, this ampersand and star will cancel each other. Ampersand star will cancel each other. Finally, you'll get star PTR. What is star PTR? Value stored at PTR, right? And you're trying to print it as a character, right? You're trying to print this as a character, right? Percentage C. You should have said, yeah, if it is percentage C, they both cancel out and you would just print A. It will just print A, right? Yeah, so it should print A. Somehow, I think I messed up my notes today. My bad. In my notes, I wrote it, I misread that percentage S. If it is percentage C, I think A is the answer. because star and ampersand will keep cancelling each other. I'll be left with star, right? Star PTR, which means value stored at PTR, and PTR is a pointer to this, right? And I'm printing just the character, which means it will just print A. Okay, so simple. That's easy. Now let's go to question 5. My mind is still on the third question, on where I messed it up. Anyway, I think I should take my mind off it and I'll solve it more peacefully, step by step. Okay. So anyway, I'll send a detailed answer, a video answer to question 3. Sorry for that mess up. Okay, so let's go to this. What will be the output of this following C program? So you have a function main, right? You have this string and it calls this fun str, right? So now let's see this. You have etag space deilppa esruoc. Okay, this is what you have. So let's look at what this function is doing. You're calling this function fun. It's taking a character array, very simple. You have a static int I equals to 0. Remember, this is a static variable, right? So static variable I equals to 0. Now, if str, what does it mean? If the value stored at str is not equal to null, if it's not a null character, right? Then you're calling function recursively. Look at this. You're calling this function recursively, right? You're calling this function recursively with str plus 1. What does it mean? I'll start here. Look at this. I'll start here. I'll literally start here, right? And I'll pass. So when I call recursively, I'm calling with the next character, with a pointer to the next character. I keep doing it till the time I reach a null character, because this is going to be stored as \0. I keep calling this function recursively till the time I reach this null character. Once I reach the null character, look at this. Once I reach the null character, right, the recursion stops. Till the time recursion keeps happening. Now, when the recursion, look at this, because I'm calling function from within function, right? When the recursion stops, what happens? I have string 1 I equals to value stored at I. Now, when the recursion stops, my I is still 0 because I never got incremented. Look at this. I'm just calling. So if you look at this, I just checked if the string is pointing to a null character or not. If it is not pointing, I keep calling fun. I've not incremented my I anywhere here. So finally, when I reach the null character, right, my recursion stops and I start unwinding the recursion. When I start unwinding the recursion, what am I doing? I'm saying string 1, look at this. I'm saying string 1 I, right? String 1 I is equal to value stored at string, right? Now, finally, what will my pointer be? My pointer will be just to C, right? My pointer will just be to C. So I'll get C now. Okay, but I'm incrementing I. Because I'm incrementing I, look at this. So first what I'll place this capital C in the 0th location. Then I will get incremented because I is a static variable. Look at this. I is a static variable. As the recursion unwinds, I'll keep getting this. I'll keep getting the reverse of the string. Course applied. I'll simply get course applied gate. Right? Applied gate. I'll simply get this string in reverse as the recursion keeps unwinding. Right? So what this returns to me eventually, again, this is a recursive function. Look at this. This is a recursive function. As the recursion unwinds, because I have a static variable, the static variable is getting incremented here. What I will finally get is I'll get a string. This is nothing but a string reversal program. This is basically a string reversal program which is implemented recursively. That's what this is, literally. Okay, so what I'll get here is course applied gate. Again, what you have to be careful about here is to understand this recursion. Look at this. I'm calling function here. This function calls function with a pointer to the next character, right? And as the unwinding happens, I'm storing everything. First, I'm storing in the 0th character. So C will go to the 0th position, right? Then O will go to the first position, and so on and so forth. So as the recursion unwinds, because I have this as a static variable, right, and I'm incrementing it here, I will get the reverse of the string. So this is a very simple program. It's a recursive program to get string reversal. Okay, so I hope this is clear. So let's go to question 6. Okay, so question 6. Okay, this is also an interesting one. This is also a 3D array, and I think mostly I didn't mess this up. Okay, so look at this statement. We have not discussed a statement like this. So what this statement does is this. It says int a567 equals to 0. So it is literally creating a 3-dimensional array, right? It's creating a 3-dimensional array, initializing all the values to 0. Okay, this type of initialization basically initializes all the values to 0. Now there is a missing statement here. It is asking us what is the missing statement, and It says printf %d A123. Which of the following could be used in the place of missing statement so that the output is 4? Very good question. Okay. So A123 is 4. Obviously, right? If I just, because this is one way of assigning 4 to A123, right? I can assign or access A123 using this statement. So certainly S1 is correct. Okay, look at all the options that I have. These are the options that I have. Is S2 correct? Let's look at this. Let's look at this statement. Okay, what does this statement mean? This statement is value stored at A plus 1. Okay, look at this. Value stored at A plus 1, right? So this now, so if A is a three-dimensional array, right? This is basically a 2D array. This is going to give me a 2D array, right? Look at this, star A plus 1 plus 2, right? So this is going to give me a 2D array. Now for this 2D array, I'm adding 2. Look at this. This is going to give me a 2D array. This is going to give me a 2D array pointing to A1. Okay, again, going from this 3D arrays to 2D arrays is the tricky part. Okay, once we do this carefully, I think we are done. Even the previous problem, I think I messed this part up. I really, my mind is still on the third question. I think this is what I messed up last time. Okay, so let's go step by step. Okay, this time I don't want to do that mistake. Okay, so star A plus 1, what does this mean? This means value stored at A plus 1. This is nothing but, look at this. This statement here is basically same as A1. And what is A1? A1 is a pointer to a 2D array. Okay, this is what it is. Now, what is the next thing that I have? I'm saying plus 2, right? So I have a pointer to a 2D array, right? And then this is a 2D array. Remember, this is a pointer to a 2D array, right? Now I'm saying plus, sorry, I also have a star right before this. This star, one second. What are the parentheses here? Star A plus 1 plus 2. So what do I get? This is what I'm assigning right now, plus 2. Okay. So when I have this plus 2, okay, see, this is a pointer to a 2D array. Now, when I have plus 2, right? When I have plus 2, this whole thing will become a pointer to A12. So this is a 1D pointer. Look at this. This is a 1D pointer. So I also have a star here, right? This star now. Yes. This is what I'm looking for. So this star A plus 1 plus 2, this whole thing is a 1D pointer to this location A12. Yeah, so this is a 1D pointer to A12. Yes. Okay. Then I have plus 3. Okay. So when I have plus 3, what am I going to get? And with a star. And with a star now. Right? So I have 1 star, 2 star, 3 star. Yes. This whole thing is going to be, give me A1, 2, 3. And I'm saying this is equal to 4. Right? So if you notice, so look at how we are unwrapping the whole thing. Okay, so this statement is also going to do A1, 2, 3 equals to 4. Okay, again, I think it is just best. Again, I'll add this additional content because there is this confusion about 3D arrays. Even I got confused, to be honest with you. That's probably because I didn't do this videos myself, right? So let me do some videos and add it to the pointers chapter with 3D arrays and all of these types of syntaxes. Okay, it's slightly tricky and it's very confusing, especially with 3D arrays. With 2D arrays, we will not get very confused, right? Similarly, if you look at statement 3, this statement 3 also, we can unravel it. Star A plus 1. Star A plus 1 is nothing but A1, right? A1 plus 2 with a star again. So this becomes A12. A12, then I have this syntax of, I have the array syntax 3. So what does this mean now? This is nothing but A12, 3. Instead of plus 3, I have this array indexing 3. Right? When I have the array indexing type of 3, what does this mean? This whole thing also means A1, 2, 3. And this is equal to 4. So S1, S2, S3, all of them are equivalent. All of them are correct. Now S4 is the tricky one. S4 is the tricky one. Okay, let's look at this. What am I doing here? I'm typecasting A into integer pointer. Look at this. I'm typecasting A into integer pointer first. Okay, then I'm saying, so if you have this whole array, where will the location be of A1, 2, 3? First, I will have the whole matrix A0. I'll have the whole matrix A0, which is of size 6 cross 7. Then, because look at how the whole thing is organized in the memory. First, I'll store whole of A0, again row wise in the row major order, right? 6 cross 7. Then my A1 starts, right? In the row major order, first I'll finish A0, then A1 starts. So how many integers are required for A0? 42 integers, right? So look at this. What am I saying here? Int A. So I've gotten an integer pointer. Look at this. A is actually the name of a 3D array, but I'm forcefully typecasting it into an integer array, right? So I got an integer array now pointing to A00, A000. So but because I'm typecasting it, I got a pointer to the 000 cell in the whole 3D matrix, right? To that, look at what I'm adding here. 1 into 6 into 7. So I've passed all of them. I've crossed all of them in the memory location. Then I'm saying go to 2 into 7, which means go 2 rows now down, right? Now I've reached, see, once I've crossed 42 integers, I've crossed whole of A0, right? I've crossed whole of A0. Next, 2 into 7. These many integers I have to cross, which means I cross first row and second row. Now I reach third row. What is this? This is my A1, 2. Now here it's saying go to the third location because I have +3 here. Okay, by location I mean number of integers, right? What is this integer location now? It is A1, 2, 3, and A1, 2, 3 equals to 4. So all these 4 statements, so the right option here is S1, S2, S3, and S4. All four of them are equivalent, and all 4 of them will place 4 into my A1, 2, 3. They're just all of them are equivalent. They're different ways of saying the same thing effectively. And all of them internally, the compiler will effectively translate everything into this internally. Okay, so this is also a slightly tricky 3D matrix question. So as I told you, just to avoid these confusions in the future, and I think it's something that I should do, and I'll add some additional videos in the course, and I'll send you those updates hopefully tomorrow or day after with 3D matrices and how to think about them. Okay, there is also one more concept I think that I missed out that one of the team members was reminding me today. Okay, so let's go to this 7th question now. Okay, so let's look at this question. It says okay, so let's do this. Okay, this is a slightly tricky one, but it's doable. So I have, look at this. What does this mean? I have a pointer of character arrays. Okay, I have an array of character pointers, right? So my str 0, 1, 2, 3, all of them are pointers of type character. They are all char stars, right? So this first one will point to sweet, right? This first one will point to sweet and \0. The second one is pointing to smile, right? The third one is pointing to end. The fourth one is pointing to repeat, right? Look at this. This is basically an array of character pointers, right? Each of them, it's an array of character pointers pointing to sweet, smile, and repeat. Next, okay, this first line is over. The second line, SPTR. This is basically, okay, look at this. This SPTR is here. Okay, let's write it down. This SPTR is also an array. So it's also an array. What is it an array of? It is a pointer to a pointer of character. Look at this. It's a pointer to a pointer of character type, which means it can point to these. Look at this. What are these? These are character pointers, right? These are pointers to character pointers. Now, what is the first value? str plus 3. So this is also of size 4. And this 0th one is pointing to the 4th, str plus 3. The second one is pointing to this one. This third one is pointing to this one. The fourth one is pointing to the 0th one. Okay, so the 0th one is pointing to this. Look at this. SPTR here. This SPTR is an array. It's an array of pointers to character point. See, each of them is a character pointer, right? Let's write that down. Each of them is a character pointer. What is this? This is a pointer to character pointers. Okay, finally, look at this more complex thing. I have star char triple star pp. So you have another variable called pp which can point to this because it is a pointer. Look at this, because it is a pointer to pointers to character. So your char can point to this. Okay, that's what it does. Look at this line, PP equals to SPTR, which means PP will point to SPTR, will point to this starting, will point to this location, literally, right? Now plus PP. Okay, let's actually write that carefully down so that there is no mistake. Okay, so where is my PP? My PP is a pointer to this, right? Now plus PP. Okay, let's see what is plus PP mean. First, I have a pre-increment, right? I'm incrementing PP, right? See, PP is pointing to the 0th location in SPTR. If I increment this, what happens? It will now point to this location, right? It will now point to, if I increment this, what will it point to? It will point to the first location, right? That's what we have done. Next, it says printf %s plus PP star star. First, let's do plus PP. I'm again incrementing PP. Now, what will PP point to? Now, PP will point to, again, writing this is very important. Now, PP will point to 2, right? Plus PP. Then it says star star. Value stored at, value stored at. So let's look at this. Value stored at P, which is this, right? So what is this pointing to? Pointing to SPTR2 is going to point to SPTR2. This will point to 3, this will point to 2, this will point to 1. Yes. Right? So SPTR2 is going to point to this. And this is going to, because you have 2 dereferencing operators, right? You have 2 stars. So this is the first star, the second star, you reach smile and you print smile here, right? You printed smile. Okay, very good. Actually, the moment you do that, right, your answer is already here because there is only one string here which starts with smile. So option A is the right option here. Of course, you can just follow the same logic here. You can again decrement PP and then look at what is stored in PP. Right? Now look at this. I'm decrementing PP, pre-decrementing PP, which means PP will now point to 1. Right? PP will now, so now star PP, which means go to this first location. The first location will go here and value stored here, which means AND. Look at this. 1 is pointing to 2, 2 is pointing to AND. So smile and eat. This is somebody like me. Oh, this is not sweet. Sweet, smile and repeat. Oh, it's okay. I think it'll not print eat, it'll print sweet, I think. Smile, eat, and sorry, there is no eat here, right? I think there is some mistake in this. There is some mistake here. Smile and let's see what happens here. Now I'm again decrementing PP, right? Again, I decrement PP, which means PP will now point to 0. Okay. Then I'm saying value stored at, so look at this. Value stored at PP plus 3. Oh, okay, got it. I understood how you get eat. Sorry. So value stored at PP, which means go to this 0, right? Value stored at this. This is pointing to this. So I'll get this string repeat. And it's saying plus 3. What does plus 3 mean? It will print eat, right? So it will print eat here. So finally it will print smile and eat. It will print the eat from repeat because this is at 0, 1, 2, third location, right? So that's how you get smile and eat. But you don't have to solve the whole thing. The first smile you get it, that's it. You can smile and just take that answer. Okay, so this is question 7. Let's go to question 8. Okay, so let's look at what's happening here. I have int main, I have A with a value of B, I have B with a value of 3, very good. I have C, which is a pointer to B, very good. Let's write down some addresses. Let's assume this is 2000, let's assume this is some 3000, and let's assume this is some 4000. So 3000 is inside this because I said C equals to address of B, right? I'm creating an integer pointer which is storing the address of B. Okay, so this is good. Next I'm calling this function. To this function, I'm passing A by value. Look at this. This value is 3, but I'm passing it by value. I'm passing B by reference, right? I'm passing B by reference here, right? And I'm passing C also by reference, right? So look at this. B is being passed by reference. C is also being passed by reference, right? So here I'm passing the address of B. Let's actually write that down. Because I'm passing the address of B, what actually goes in here is 3000 because address of B is 3000. Next, I'm passing the address of C. Address of C is 4000. Now let's look at it. It says PTR1 equals to 2. PTR1 is a local variable because I copied this value. I passed A by value, not by reference. So nothing happens to A because PTR1 is a local variable. On the other hand, star PTR2, equals to PTR1, which means value stored at PTR2. What is PTR2? 3000. So value stored at 3000 equals to PTR1. What is PTR1? 2. So value stored at 3000 is 2. So this value will become 2. Very good. Then value stored at PTR3. Right? What is PTR3? PTR3 is 4000. So value stored at PTR3, which is 3000, value stored at 3000, this value is equal to value stored at PTR2, which means 2 itself. And PTR1 equals to 1. This is a local variable, right? Its scope is local, right? As soon as you come out, it will die. Now here I'm trying to print ABC. What is the value of A? A is 3. What is the value of B? B is 2. What is the value of value stored at C? It's again 2. So 3, 2, 2. That's all. Okay. Here, so again, by the way, this is something. So this is called a double pointer. Okay. You have pointer to a pointer. So it's called double pointers. These are called triple pointers. Pointer to a pointer to a pointer. Okay. So this could get slightly tricky, but as long as you read them as value stored at, value stored at, value stored at, you're cool. Okay. So don't worry about it. It's fairly straightforward. Now let's go to question 9. Okay. So what's happening in question 9 now? This is a straightforward problem. Okay. So what does this function do? Let's try to understand logically what it does. Okay. I could go, see, if you notice, I'm not going line by line, because taking some input, taking a long input like this and going line by line will take too much time in the examination, right? So you have to understand logically what is the program trying to do. Okay. So if I pass a string, look at this, I'm passing a string here and I'm printing this string finally. When I pass the string, what does it do? If P equals to null, okay, which means the string is empty, or value stored at P is null, okay, return 0. Very good. Otherwise, current equals to 1, I equals to 1. Okay. While value stored at P plus current, suppose if I pass this whole string, let's say I pass this whole string, APP LIED DEIL PPA. This is what I'm passing this, right? So your P is a pointer to this. P is a pointer. It's a character pointer to the first character. So what is current? Current equals to 1. Okay. So this is 0. This is 1. This is 2. This is 3, 4, 5, 6, so on and so forth, right? So P plus 1. P plus 1 means this is the value stored at P plus 1. P plus 1 is P, right? While this value is not equal to 0, which means this will keep repeating. This loop will keep repeating till the time I reach the end of the string. That's what this loop does. Now look at the logic inside the loop. What is the logic inside? So this loop will continue till the time I reach the end of the string. Right? That's what this means, right? So if I'm at this, if I'm at this string, sorry, if I'm at this character, it will stop, because the next character, because my current here equals to 1, right? Again, your current itself could change, so you have to be careful with that. If P current is not equal to P current minus 1, okay, so if it is not equal to, okay, so here what happens? Your P current equals to 1, so P current is small p, is not equal to P current minus 1. P current minus 1 is A, so this is not equal to this. Okay, then it says Pi equals to P current. What is I now? I equals to 1, right? Pi equals to P current. What is P current now? Your current is 1. Yes. So this will remain P now, and I gets incremented, right? That's what is happening in this loop. Then once you come out of this loop, your current gets incremented. Look at this. Current is constantly getting incremented, right? Current is constantly getting incremented, which is good, which means you go from one character to the next character, to the next character, to the next character, so on and so forth, because current is continuously getting incremented. And the while loop, look at the while loop itself, right? The while loop itself has P plus current, right? What is this if condition trying to check? This is important. See, this while loop, we understood that it will continue till the time you reach the end, right? That's what it's trying to do. It's constantly checking till the time you reach the end. But what is this trying to do? Okay, imagine a situation like this, right? Imagine a condition where this fails, because we saw a condition where this is true, right? What happens if this condition, if P current, look at this, suppose my current is here, let's say my current equals to 2. Let's say my current equals to 2. Okay, so now what is P current? P current is small p. What is P current minus 1? It is also small p, and they both are equivalent. When they both are equivalent, what is happening? My current is simply getting incremented, right? There is no copying that's happening. There is no copying that's happening. My current simply gets incremented. My I is not getting incremented. Look at this. When they both are the same, look at this case, right? When they both are the same, my I is not getting incremented, only my current is getting incremented. So now my current becomes 3. Okay, again, this condition it satisfies. Now look at this. Now look at this. Is my P current now? What is my I now? My I will still be equal to 2. Right? My I will be equal to 2, but my current has become 3. Because current got incremented here, I did not get incremented. Right? So now what happens? Now look at the case that it will run into. Now what happens? Your P current is now L. L is not equal to P. That's very true, right? Then what is it doing? It is basically changing P2 equals to P current, which means it is clearing this P and placing this L here. So what is it literally doing? If you think about it logically enough, whenever you have duplicates, look at this. Whenever I had this duplicate, whenever I have 2 consecutive words that are the same, it is simply not incrementing the I, which means it will override this with this. That's what it's trying to do, right? Again, the reason I want you to understand the logic of what's happening internally is because that is a more robust way to understand code than to just do it manually for a given input, right? So whenever you have two characters that are the same consecutively, it is replacing this character with the next character. And how is it doing it? By not incrementing I, but by incrementing current every time. So literally what it does is, whenever there are 2 characters next to each other which are the same, like this, it will delete this effectively. So it will also remove this. It will also remove this, right? So what you get now is finally going to be a string like this. Finally, again, look at this line. Finally, once everything is over, it is placing a null character at the end to signify that I've reached the end of the string. Okay, so this, again, the logic part is important. The key logic part that's happening here is this while loop is running as long as for the whole string. This is checking. Again, I is basically where I am right now in the editing process. This is checking if the current character and the previous character are the same or not. If they are the same, I don't increment my I, which means I'll replace that. Okay, and that's the logic here. Understanding the logic is the key sometimes. Okay, so whenever you have 2 consecutive characters which are the same, I'm going to replace this with the next character. That's what is happening here. And the answer here is C. Okay, so if I give you a much longer input, right, and if I can give you very confusing outputs here. Okay, so in such a case, going through this long input and processing it manually will take forever. It is better to understand the logic and see what's happening. Okay, and that's also conceptually better for you. Okay, so let's go to question 10 now. Okay, so this is interesting. I have char p, applied course, very good. So I equals to 0, j equals to string length p. Okay, let's look at this. I equals to 0. Okay, my I equals to 0. J equals to string length. What is the string length? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, my j equals to 13, while I is less than j. Okay, look at this loop. As long as I is less than j, this loop will keep continuing. But here is the fun. I is getting incremented and j is getting decremented. Okay, so what is happening now? Let's look at this. So t equals to pi. Okay, what is pi now? P is my string. What is pi? P13. What is P0? So t equals to P0. Okay, so what is t now? T is going to be a. Pi equals to Pj. What is Pj? P13. What is there in P13 actually? Because indexing in this starts with 0. So P13 is actually \0. P13 is actually \0. So pi becomes \0, which means I'm replacing the starting of the string itself with \0. And I'm saying pj equals to t. Okay, so I'm just moving this a to the 13th character. So 0, 1, 2, 3, so on and so forth, up to 13, right? So look at this. Because I said j equals to 13 and not j equals to 12. If I said j equals to 12, everything would have been all right. This e would have, basically what am I doing here? I'm swapping the first and the last characters, literally. But in the code, because I said j equals to string length and not string length minus 1, this \0 got replaced with a. So they both got swapped, right? Instead of a and e getting swapped. So this is a slightly erroneous code, for string reversal. This is also a string reversal code, but with a small error that you're initializing A to string length and not string length -1. So what is the final string that you would get? The final string that you would get, again, you can keep running this loop. What will literally happen is it's trying to swap these two using a temporary variable called t. That's what it's trying to do logically here. But the very first character itself is a null character, right? So finally, when you try to print p, if the first character itself is null character and there is no null character at the end, see, how do strings get printed? Till the time I encounter a null character, I'll print everything. If the very first character is null character, it will print nothing. So nothing is printed here. Okay, so this is a erroneous implementation of string reversal where I'm messing up these two. That's what is happening here. Okay, so this is question 10. This is also a very nice twisted question. Okay, so let's go to question 11. So this is my character array. Okay, this is my character array. Very good. P is a pointer to C. So P is pointing to this. P is a character pointer. Now I'm saying printf %s, and I have an arithmetic expression here. P plus. So P is a character pointer. Very good. Now P4. What is P4? 0, 1, 2, 3, 4. P4 is character I. P4 is a character I, right? Because P is a character pointer. Okay. P4 is basically the fourth character from here. 0, 1, 2, 3, 4. It is I, right? And what is P0? P0 is A. Now what is I minus A? It will take the ASCII values of I and A. A is 65. I don't remember for I. But B I know is 66. C I know is 67. So on and so forth. What is the difference between I and A? Look at this. A, B, C, D, E, F, G, H, I. Right? I know for sure. Okay. So if this is 0, 1, 2, 3, 4, 5, 6, 7, 8. So this difference is going to be 8. Because I know capital A, capital B, up to capital I are all sequential in the ASCII values. So I'm saying P plus I. What do I want to print? P plus 8 is what I want to print. Because I minus A, right? Because I minus A is 8. So P plus 8 is what I want to print. What does P plus 8 mean? 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is the pointer of P plus 8. So I want to print everything till the time I encounter \0. So what would this print? This would simply print course. Yes, because it will print CO. Yeah, it will print this with \0, right? So this 11 will print option B. Again, very simple. Here you have some arithmetic operations, some ASCII values. That's it. Very straightforward question here. Okay, let's go to question 12. Okay, this is also a good question actually. So what is a missing statement in the following statements? Okay, let's look at this. What is the missing statements? Okay, which copies? Okay, you want to copy from string X to string Y. That's what you want to copy. Again, this is like your strcpy, right? This is like your string copy. How do you implement string copy? It's actually very simple. Okay, look at this. Look at this code. So you're given a character pointer and you're given a character pointer while the character pointer in Y. So you're trying to copy this into this, which copies string X into string Y, not the other way. Okay, it's trying to copy string X into string Y. String X into string Y. Okay, that's what it says, right? So while Y is not equal to null character, very good. And okay, finally you're placing this. What is the missing statement here? What should be there in this while loop? Look at all these options. What about this? What does this mean? Let's go one by one. What does this mean? This means value stored at X equals to value stored at Y. Imagine the character pointers are, let's say I have ABC here. Let's assume I have ABC \0, and let's assume I have XYZ. I'm just taking a simpler example. Let's assume my X is pointing to this and my Y is pointing to this. Right? Let's assume this is what I have. Actually, it should be Y to X, not the other way around, I think. Okay, let's see. Anyway, you want to copy one string to other string, basically. So what does this mean? What does this mean? What does this do? So star X equals to star Y, which means value stored at X is equal to value stored at Y. So you're copying this X from here to here. This X you're copying from here to here. Right? And then you're incrementing this X and these are post increments. Once I've done that, I'm incrementing my X to point to the next character, my Y also to point to the next character. If I keep doing this, look at this. If I keep copying the next character, because these are pointers, right? Because I have these pointers, I can keep making them point to the next character one after the other and keep copying till the time I encounter the null character. So option A is the simplest right option here. Okay, it's very, very simple. I'm copying this value to this value, and I'm incrementing my x and y one by one. That's all I'm doing here. Okay, again, very simple, straightforward problem. Actually, if you want to implement string copy, this is one of the simplest implementations of string copy. Literally 3 lines of code. Okay, so now let's go to question 13. Okay, let's see what's happening here. You have int p, malloc size of int. So I've created some memory which can store, let's say int is 2 bytes, and p is now a pointer to this, right? P has, let's say this is at address 2000. P has a value of 2000. Now what am I doing? I'm saying p equals to null. Okay, which means what is the value at p now? P value, I made it null, which means 0, which means this is no more a pointer. Now I'm saying free p. P is not pointing to anything, right? What will p free, right? P is pointing to null. P is pointing to null. So it doesn't actually free up this space. And there is no more pointer to this space also. Look at this. This has become a dangling pointer now. This has become memory leak, not dangling pointer. This has become memory leak now, right? Because there is no pointer to this memory is not deallocated. I'm not freeing up this memory because I've changed p itself to null. If I want to free up this memory, I should have done this free p and then p equals to null. If I had written free p, then p equals to null, then obviously this would have gotten freed up, and then I would have made p point to null. This is the right sequence of statements, not this. So when you have this, what happens? You'll get a memory leak, not a dangling pointer. You'll get a memory leak. That's it, right? Because there is some memory which you have not deallocated, but there is no pointer left to it because you change the pointer value to null without having any other pointer pointing to this, right? So this is a problem of memory leak. So let's go to question 14. Okay, again, your 3D arrays. Okay, let's go to this. Okay, so you have, okay, I'll be careful here again. Okay, let's go slowly, step by step. Okay, this is something that I'm messing up. I mean, I lost my confidence after screwing up the third question. But let me see. Let me do it carefully now. I have array 2, 3, 3. I have this thing. Okay, so I have 2 3 cross 3 arrays. Right? Look at this. I have 2 3 cross 3 arrays. So let's actually write down the 2 arrays. Okay, so my first array is it's a 3 cross 3 array, right? It's a 3 cross 3 array, and I have 2 3 cross 3 arrays. This is what I have, right? Now my array. Okay, so this is what I have. Very good. So what do I have? I have applied A P P L I E D. Is there a space? Yes, there is a space. C O U R S E \0. All these are also nulls. Okay, very good. Now what am I saying? All this is the array name is ARR. Very good. Now P, look at this. P is a character pointer of type 3D. It's a 3D pointer, right? It's a 3D pointer. P is a 3D pointer. P is a pointer to a 3D array. That's what I mean when I say 3D pointer. Okay. P is a pointer. Okay. But it's a pointer to a 3D matrix of type char, and to which I'm storing the address of R. Right? I'm just giving the address of R itself here. Okay. I'm giving the address of R itself here. Okay. So P is a pointer pointing to the address of R. Okay. Now let's see. Let's look at this command. What does this command do? It says *p0. Okay. Let's see *p0. Okay. *p. Where is this? Sorry. *p0. And to that. Okay. What is the sequence here? 1 second. Let me see the parenthesis here. *p0 and then there is a star. Okay. Then there is a star and then there is +5. Right? So that's the sequence, right? *p0 and then star. Yes. Okay. So what is *p now? *p is the value stored. Look at this. *p means when I did *p0. Okay. So the moment I say *p, right? What does *p mean? It's a value stored at p. Right? The value stored at p, you would get this whole 3D array. Right? Because p is a pointer. Look at this. P is a pointer to 3D array. So *p will give you the 3D array. *p0. Look at this. *p0 star. Okay, this is the next step, right? 1 second. Again, I'm getting confused here because I've written, okay, let me tell you what I've written in the notes. I think I messed it up again, but let's go step by step. Okay. Now, what does star P mean? P is a pointer to a 3D array. P is a pointer to a 3D array of type applied, right? Okay, that's good. Now star P, again, I think I'll do this carefully. I think I'm getting confused again. Let me just take a step back. I'll answer question 3 and question 14. I'll just create video answers for both of them and send it to you. Okay. I don't want to make a mistake again because I think I'm getting slightly confused with the notation because my team is telling me something, I'm thinking something, and I'm getting confused because I think when I wrote my own notes on my own, I might have messed it up. Okay. Anyway, so I'll solve question 3, question 14 more carefully, and I'll do some content. I think if you solve a couple of questions with 3D arrays, the concept will become clearer. Okay. Next, I think question 15 is a topic that we did not cover. So the question 15 is about function pointers. Okay, question 15 is about a concept called function pointers that I don't think I've covered as of now. I'll add this miscellaneous topic maybe a day or two later, because I think the answer for this is D. For those of you who know function pointers, the answer here is D. For those of you who don't know, don't worry. I'll create some more videos for function pointers. Initially, I thought these function pointers are not part of syllabus, but it's not clearly mentioned in the GATE syllabus. I've not seen previous questions also which cover function pointers, but we thought why not cover it? Because just because GATE has never asked a question like this, because they have not clearly stated that function pointers is not in syllabus, right? So we created a question on that front, but since I have not covered it, I'll create, when I create the content for function pointers, I'll solve the problem there itself as one of the solved problems. Okay, I hope this is clear. And sorry for messing up question 3 and question 14. I will go detailed. I'll actually draw more diagrams there. I think the best way to understand 3D arrays, especially 3D arrays, which are super confusing, or 4D arrays for that matter, which are more confusing than 3D arrays, is to actually draw diagrams carefully and understand. I'll solve these problems, which will also clarify it for you. Which will also, I don't want to make a mistake in live right now, because that'll be terrible, and you'll also misunderstand. Okay, I don't want to do that. Okay, having said that, just a second. Let me stop this here. Okay, I'm stopping the screen share here. Okay, I'm back, and let me look at the chat session. Okay, so nothing is printed. Hey, Arnab, your point is right. I think that question, right? This question, we're trying to copy X to Y. I think I'm also confused with that, because there is also an option. Arnab mentioned in the live session, live point right now, that none of the above should be the right option there, because we are copying from Y to X, not X to Y, right? So I think that's also a case. So I'm not sure whether we wrote the question incorrectly or option D is the right option. So I'll just get it confirmed and update the question if there is a mistake, or update the answer. Okay, so that's a confusion that I also had while I was solving it. Okay, sorry folks, I messed up 1 or 2 questions. Yeah, so somebody's saying this is the most conceptual test. Obviously, pointers is the most conceptual stuff. It's very, very easy to make mistakes, right? I mean, it's been a while I did some of these problems. It's been many years, right? Yeah, I will add more problems. Actually, I have like over 50 problems for pointers and strings. I've just not gotten time to actually solve them. I'll start solving them. That's something that I'll do. Again, once the whole course is done, we'll have a couple of days, right? We'll solve lots of problems with pointers. Okay, that's the only way we all become good. Okay, so trust me, we have a pile of problems with just pointers, mostly pointers. I'm sitting on a list of 50 problems right now. Some of them we have created, some of them we have done from GATE, etc. Sir, where should we preferably check for more GATE related questions? So here, so what is happening here is, for GATE related questions, actually, if you look at just the GATE old questions, right, there are like hundreds of questions, because right now there are, I think, 3 sets, right, for GATE from the most recent past. So if you just look at last 5 years or last 6 years questions, there are like hundreds of questions in C. I mean, C is a very important topic, by the way, because people who set the GATE question paper expect this to be a scoring subject if people know the concepts clearly. So if you just want to practice C questions, just look at the last 20, 30 years of questions. Again, we'll give you tons of questions. in a couple of days, once we finish all the content, we'll give you tons of practice. We're literally sitting on, like, just for pointers, I'm sitting on 50 questions, right? So we'll add more solved problems. We'll also give you tons of practice problems. Don't worry about that. Okay. So yeah. Okay. So this is good. Okay. Any other questions here? Okay, so yeah, I think everything is taken. I'm glad that some of you are answering the questions here. Yeah, we have already tested all of this code in IDE1 or other places. We want to cross check our own answers when we set some of these questions, right? So okay, sounds good, folks. Thank you very much, and yeah, thank you very much, and yeah, sorry for the mess up with a couple of questions with 3D pointers. I'll create detailed answers and send them to you. Okay, see you again. See you next Wednesday. Hopefully by next Wednesday, we should finish most of it. We should finish most of C programming. And we'll also give you some subject-wise tests with a special focus on pointers, functions, recursion, etc. Okay, see you then. Bye-bye.